Hi everybody, this is Miss Faina. Today we're going to be talking about slope, or it's also called rate of change. Okay, so we have some different methods for finding the rate of change or slope. So if we're given a graph, you get to choose two pretty points. Pretty points really just means they go through nice easy numbers like 1, 1, 2, 1, okay, where we can identify the point and we don't have to guesstimate. Okay, and then you count the rise over the run, or use the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, when you're given two ordered pairs, we just like to use the slope formula, and then if we're given a table, it's the same thing as an ordered pair. So again, we would use the slope formula. So this is an important formula that you need to know right here. Okay, also you need to know rise over run, because sometimes that might just be easier. So, from a graph, what we want to do first is find two pretty points. So if we look right down here, it goes through a nice whole number. Okay, and then if we look again, right here is a nice whole number. So what we're talking about, rise over run. If I start here, how many do I need to go up before I get to the same y value that my other point is at? Well, I go up 1, 2, 3, 4 spots. And how many do I need to run to get to that point? Well, I go over 1, 2, 3, 4, 5, 6. So my rise equals 4 over my run, which equals 6. Now, with slope, it needs to be in simplest form, which means we need to reduce that. So we're going to go straight to our calculator, and we're going to type in, first we go to New, Calculator, and we type in 4 divided by 6. It simplifies for us to 2/3. So my slope, or my m, would be 2/3. Okay, the other method we said was to use the slope formula. So to do that, you need to label your points. So this point would be 2, 0, and this point would be -4, -4. Okay, so I'm going to rewrite those points. So I have 2, 0, -4, -4. Okay, this is my x1 and this is my y1 because it's the first point I have listed. This is my x2 and my y2 because it's the second point I have listed. So our formula is y sub 2 minus y sub 1. So I'm going to take a -4 minus 0 over x sub 2, so -4 minus 2. And then from here, all I'm going to do is type it in the handy dandy calculator. So I'm going to put it in parentheses. -4 minus 0, close parentheses, and then do my fraction button, and I had -4 minus 2. I press enter. I get 2/3 as well. So just to show you that no matter which way you do it, you get the same exact answer. Okay, and if we look, the slope is going up, it's increasing from left to right, which means it's a positive slope, and we got a positive answer for our slope. Okay, so let's look at this one. Let's find two pretty points. So it looks like right here's a pretty point, and right here's a pretty point. Okay, there may be different pretty points. It honestly doesn't matter. So if we're doing the rise over run method, notice this time we go down and then we go over in the positive direction. Well, I went down 1, 2, so that's a -2. And I went over 1, 2, 3, 4. So my rise was a -2 over my run, which was a +4. Okay, we go to our calculator to have it simplify for us. -2 over 4 we get a negative 1/2, which would be my slope. Or again, we could label the 2 points and use the slope formula. So this would be -3, 3. This would be 1, 1. So I have 1, 1, -3, 3. So this is my first point, so I label it x1 and y1. This is my second point, so I label it x2 and y2. And I plug it into the handy dandy formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then from here, I'm just going to type that into my handy dandy calculator. So 3 minus 1 and -3 minus 1. So 3 minus 1, oops, parentheses, 3 minus 1, close parentheses, fraction button, -3 minus 1. Again, I get a -1/2. So it does not matter which way you solve it. Now, if you notice, left to right, this is decreasing and a negative slope. So decreasing and negative slope go together versus increasing and positive slope like we had with our first example. Okay, so looking at this, notice we have a horizontal line. Okay, a horizontal line. So if we pick 2 pretty points, let's just pick here and here. Okay, notice I don't have a rise, so my rise would be 0 because I'm not going up any, and I go over 1, 2, 3, my run would be 3. So I don't go up any, that's why I have a rise of 0, and I go over 3 for the point I selected. If I type that in the calculator, 0 divided by 3 gives me 0. So this is what a 0 slope would look like. And again, that was using the rise over run method. Okay, if I wanted to use the 2 points, I have -2, 2, and I have 1, 2. So I use my 2 points. x1, y1, x2, y2, because it's the second point. And I plug and chuck. So I have 2 minus 2 over -2 minus 1. Okay, I'm going to type that into my handy dandy calculator. So 2 minus 2 over -2 minus 1. Type it in, I get 0. So again, it does not matter which way you want to solve this. It's whatever's easiest for you. You can solve it that way and get the same answer. Okay, now let's look at this one. This is now a vertical line. So again, pick 2 points. So let's pick these 2 points right here. Okay, notice I have a rise this time. So I am rising this time. I'm going up 1, 2. But I'm not running any. Okay, I don't go left or right, so I have no run. Well, when I type this into my calculator, let's see what we get. 2 divided by 0. You get undefined. Okay, that's what that means, undefined. This is an undefined slope. Okay, why is it undefined? Because you can never divide by 0. Cannot divide by 0. If we wanted to see what it looks like using the slope formula, I have the point -2, 3 and -2, 1. So I use my 2 points, -2, 1, -2, 3. My first point, y1 and y2, or x1 and y1. My second point, x2 and y2. I plug it into the formula, y sub 2 minus y sub 1 over x sub 2 minus, be careful with that because it's a negative 2. And I'm just going to type that into my handy dandy calculator. So we have 3 minus 1. And then on bottom we have a negative 2 minus a negative 2. And you also get undefined. Okay, so showing you that both methods work. Perfect. So there's 4 examples of finding the slope from a graph. And I showed you rise over run, and I also showed you using the slope formula. Now, when we have ordered pairs, okay, all you have to do here is use the slope formula. Now, it may be helpful for you to write this in the form of a table. So what I mean by that is if we have our XY table right here, I have the point -4, -4, and I have the point 2, 0. That may help you distinguish between the X values and the Y values, okay? If it doesn't, then you don't have to worry about doing it. Me personally, I like to just label my first point is X1 and Y1, and my second point is X2 and Y2, and then we plug it into the formula. I like to write the formula just so I remember it. So we have Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. It's kind of a little catchy song now. I think we'll make it a song. So we have 0 minus a -4. Be careful, the minus sign is a part of the formula, but we're plugging in a -4. And then I have 2 minus another -4. So again, be careful with that. So I'm just going to go and type that into my handy dandy calculator just like that. So 0 minus a -4 and 2 minus a -4. So 0 minus a -4. Oh, I need to put that in parentheses so I can use the fraction button. So 0 minus a -4. And then it was 2 minus a -4. When we do that, we get 2/3. Okay, so my slope m equals 2/3. Not too bad. Okay, so you go ahead and pause the video and see if you can do this one on your own. So hopefully you paused it. Again, labeling X1, Y1, X2, Y2, and then we're just going to use our handy dandy formula, Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. It's really catchy, I know. So we have our Y2, which is 2, minus our Y1, which is 3, over our X2, which is -1, and our X1, which is a -3. Again, be careful because it's minus and negative. And then we're just going to plug it into our handy dandy calculator. So 2 minus 3, and then -1 minus a -3. So 2 minus 3, and then a -1 minus a -3. Enter. We get a -1/2. And that would be our slope. Hopefully this isn't too terrible. Okay. Go ahead and pause and try this one on your own. So hopefully you paused it and you were able to figure it out. Let's see how you did. So X sub 1, yeah, Y sub 1, X sub 2, Y sub 2. So my formula, Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. Okay, we plug it in. So my Y sub 2 is a positive 2, minus my Y sub 1, which is 2, over X sub 2, which is 4, and then minus X sub 1, which is a -3. Again, please be careful with that. So I'm going to type that into our handy dandy calculator. 2 minus 2, 3 minus a -3. So we have 2 minus 2, and then I already forgot it. 4 minus a negative 3. There we go. 4 minus a negative 3. And we get 0. Slope is 0. So do we remember what that kind of line looks like? Is it that horizontal line or that vertical line? If we forgot, we can look back up here. It is that horizontal line. So that would be a horizontal line with the slope of 0. Okay, pause and try this one on your own. So hopefully you gave it a try. Again, we have x sub 1, y sub 1, x sub 2, y sub 2. And again, it's my first point is my 1s, my second point is my 2s. Nothing too bad. Our handy dandy formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, and then we just plug it in. So we have y sub 2, which is negative 4, minus 3. And then we have a negative 2 minus a negative 2. And then we're just going to plug that into the formula. Or into the calculator. So let's see. We had a negative 4 minus 3 over a negative 2 minus a negative 2. When we do that, we get undefined. And remember, that's that vertical line that we saw. So our slope is undefined. Which means it's that vertical line going up and down. So that's what it looks like from an ordered pair. Again, we're just using that slope formula, and I find it handy if we write out the formula each and every time because it just helps you memorize it better. Okay, and remember, if you need to, you can always do a table like I did on that very first one if it helps you see the x's and the y's better. Okay, now we have 2 tables. Okay, not too bad. When we have 2 tables, all we need to do is pick 2 points, any 2 points from the table. So me, I'm going to pick this 5, 0, or negative 5, 0, and this negative 2, 6. Okay, so this is going to be my x sub 1, this is going to be my y sub 1, this is going to be my x sub 2, and this is going to be my y sub 2 right there. And I'm just going to plug it into the handy dandy formula. So again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so here we go. So y sub 2 would be 6 minus y sub 1, which would be 0. I have x sub 2, which is a negative 2, minus x sub 1, which is a negative 5. And I'm just going to plug this into the handy dandy calculator. Okay, so here we go. 6 minus 0, and then negative 2 minus a negative 5. So 6 minus 0, and then a negative 2 minus a negative 5, and I get 2. Okay, if we wanted to double check ourselves because we weren't sure, we can pick another 2 points if we wanted to. So let's pick the 4, 18, and the 7 and 24. So I'm going to switch colors. Okay, so let's let this be my x sub 1 and my y sub 1, and this be my x sub 2 and my y sub 2. So again, I'm going to plug the same numbers, or the numbers that I have, into the same exact formula. So I have y sub 2, which is 24, minus y sub 1, which is 18, over x sub 2 of 7 minus x sub 1 of 4. So I have 24 minus 18 and 7 minus 4. So we're going to type that into the calculator. Whoops. And then 7 minus 4. When we do that, we also get 2. So I'm hoping that you see it doesn't matter what 2 points you pick, the slope is going to be the same, okay, when it's a linear function. It has that constant rate of change. Okay, so go ahead and pause this and try this table on your own. Okay, so I'm going to pick the point, let's see, 0, -1, and let's just do the one right next to it. Okay, so again, my formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so my x, my y1, my x2, my y2. Okay, from here, let's see. Y sub 2 is a -1 minus 1, because that's y sub 1, over x sub 2, which is 2, minus 0. I'm just going to type that into my handy-dandy calculator. -1 minus 1, 2 minus 0. Okay. -1 minus 1, 2 minus 0. And I get a -1 as my slope. So hopefully you were able to get that on your own. Again, doesn't matter what points you pick, you should get the same result. Okay? Now, from an equation, remember, when it's in y equals mx plus b form, our slope is n. Well, this equation's in that form, so our slope is 1/2. So n equals 1/2. That's what we did the other day, identifying m and b. Okay. Again, this is in y equals mx plus b form. My slope is -3. Now, if we look at this, this is not in y equals mx plus b form. This is in standard form. Okay. When it's in standard form, we have to put it in slope-intercept form. Okay, and to do that, we solve for y. Okay, that's what we want to do. So to solve for y, we need to move over anything that's not the y term, which means we need to move over that 2x by doing the opposite. So we subtract 2x from both sides. Okay, remember that 2x and that 8 are not like terms. So we cannot combine them, so we just leave it as 8 minus 2x. From here, we need to divide everything by the number in front of y. So those make a 1y. Then we're left with just an 8 over 3 minus 2 over 3x. And this is our slope-intercept form. And remember, we talked about the slope is always the number in front of the x. Well, the number in front of the x is a -2/3. So my slope, my m, is just a -2/3. Okay, so I want you to go ahead and see if you can figure this one out. It has a little extra step to it. Okay, so hopefully you tried. Now, the first thing I noticed is that I have like terms, but they're on opposite sides. This -1 and this 10, they're like terms, so we need to combine them. But because they're on opposite sides, we have to do the opposite, which means we need to move over that 1. So to do so, I add 1 to both sides. And because they're like terms, I can actually combine them. So I'm left with 10 plus 1, which is 11. Now, my goal is still to get y by itself. So I need to move over that 4x. To do so, I subtract 4x from both sides. Subtract 4x from both sides. Those zero out. I'm left with y equals 11 minus 4x. And lo and behold, I have it in slope-intercept form. And my slope is always the number in front of x, which makes my slope -4. Perfect. Okay, so we found our slope, we solved for y. We're professional mathematicians over here. Okay, now we have some real-world situations. So let's see what we have. It says, at what rate of change are the number of balloon hats decreasing? So do we see that we have balloon hat creations, we have the number of balloon hats, and the remaining balloon hats. So Something that might just be easier is using the x and y intercepts because those are already pretty points. So it looks like I have a point at 0, 500. And then I have a point here which looks to be at 100, 0. I am just going to use the formula. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to label my points. This is x1, y1, x2, y2. So my y2 is 0 minus my y1 of 500 over my x2 of 100 minus 0. Okay, and we type that into our handy dandy calculator. So 0 minus 500 and 100 minus 0. So 0 minus 500 and then 100 minus 0. And I get -5. So what was our question again? At what rate of change are the number of balloons hat decreasing? They're decreasing by 5. Okay, so my slope is a -5. Perfect. Now let's look at this one. At what rate are the numbers of meals packed increasing over time? Okay, so we have meals packed and time. So let's see. Let's start at 0, 0. And let's see. Let's do this point right here, which would be 250. And then we use the point 0, 0. So x1, y1, x2, y2. So again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's see. So y sub 2 is 0 minus 250 over x sub 2 of 0 minus 2. So we're going to type that into our handy dandy calculator. 0 minus 250, and then 0 minus 2. Looks like we get 125. So at what rate are the number of meals packed increasing over time? Well, it looks like 125 meals per hour. Which meant my slope is 125, or 125 over 1 because it's the same thing. Okay, so if you have any questions, please make sure you reach out to your teacher, you ask them for help. Other than that, have a great day, Rangers.